So in this video, I'm going to discuss the fair distribution problem which occurred in today's CODECHEF challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I'll provide both the links in the comment section. I'll pin them. The problem statement is very simple. You're given a string, which is a binary string, and whichever is 0 is going to be the toy that Alex gets, or like A gets, and whichever is 1 is what B gets. Okay, like let me simplify the names. And we have to find that the difference between the total value of those toys is it possible to make it greater than the maximum value of getting a toy. Okay, now what we know is it is given in the value of the toys are given in an order that is in ascending order. Okay, so the value of this toy which goes to 0, that is which goes to A, is greater than equal to the value of this toy which goes to B, is greater than equal to this which goes to A, and this which goes to B. Okay, like something like this. Okay, and so like the difference of what A gets and B gets should not exceed this thing. Okay, the value of this thing. If it is possible to do so, then write yes, else write no. Okay, so problem statement is very simple. Now, like I won't get into test cases like why this happens or what is the intuition. Like, yeah, I will like tell you the what is the intuition behind this, but like I will be like straight away going to going to the thing that this is a greedy approach. Okay, so before explaining, this is a greedy approach. Now, why is it a greedy approach? Because over here we are told that this thing is going to be the maximum value. Okay, maximum possible value, and the best approach is to make the value of this thing 1. Okay, make the value of this thing 1, because we have an option that the values are greater than equal to 0. So if it is 1, so it is always easy for us to understand whether it is possible to make the difference of values greater than 1 or not. Okay, so the best approach is make this 1. Okay, now what is the greedy approach we are going to do? We are going to follow. So we are going to first of all make all the elements 1. Okay, and since this is so let's say for this one, okay, for this one 0 1 0 1 0 1. Okay, 0 1 0 1 0 1. So this is the binary string. Okay, and now I'm going to make the value thing. So all of them, if all of them are costing 1, so what is, like, how many does A get? A gets 1 2 3, right? A gets, the total value of A is 1 2 3, that is 3, and total value of B is 1 2 3. Okay, so what is the difference? It is 0. So is 0 greater than 1? Nope, it is not greater than 1. So now we have to apply a greedy approach, that is make this 0. Okay, remember one thing, it has to be in ascending order, so we can't eliminate a 0 from the between. Okay, so it won't be anymore in ascending order, so we are going to start eliminating the ones from here. Now how many are A are getting? So what is the value of A? So it was earlier 3. Now the value of this thing that A gets is becomes 0, so it becomes 2 now. Okay, so this becomes 2. So 3 minus 2 is 1. Is it greater than 1? Nope. So now we are going to delete this and make it 0, and so this becomes 2. 2 minus 2, 0, not greater than 1. Make this 0, this becomes 1. 2 minus 1, 1, not greater than 1. Then this thing, then 1, 1 minus 1, 0, not greater than 1. This, so this becomes 0, 1 minus 0, 1, not greater than 1. And this finally, 0 minus 0 is 0, which is not greater than 1. Okay, very simple. So since at no position it was greater than 1, so we can directly write it's a yes. So that is, we were checking for this one, right? So this is a yes. Clear? Now let's take this one. Okay, 1 1 0 0. Okay, 1 1 0 0. So correspondingly all of them are 1. Okay, so A is equal to 2 and B is equal to 2. Okay, because like 0 is having 2 and this is having 2. Now we are going to delete this thing 0. So B is going to get a 1 less. So 2 minus 1 is 1. It is greater than 0, greater than 1. Nope. So now after we come to here, that is, it is becoming a 0. So now this becomes 0, and 2 minus 0 is 2, right? And see, 2 is greater than 1, right? So since 2 is greater than 1, it's a no. It's a no. Similarly for this also, you can see that A was 4, Okay, A was 4 and B is 1. So 4 minus 1, 3. It is already greater than 1. So it's a no. For this, okay, for this we checked. For this, okay, A is equal to 2, B is equal to 2. Okay. So this gets cancelled out. Now B becomes 1. So 2 minus 1, 1. Okay. It is still satisfying. Now this becomes cancelling. So this is 1. Now this cancels out. Okay, so again 0, and then again this cancels out, again 0. So at no position the difference of them became greater than 1. For this 0 0, so A is initially 2 and B is initially 0, right? So initially 2 minus 0, that is 2. 2 is greater than 1, so it's a no. Okay, and for this it is 1. So A is basically what? A is basically 0 and B is equal to 1 over here, right? So this is 1. So 1 is 1 minus 0. So 1 minus 0 is 1. 1 greater than 1. Nope. Now if we delete this, so this becomes 0, and 0 minus 0 is 0. So is 0 greater than 1? Nope. So it's a yes. Okay. Very much clear. I explained all the test cases, why it is happening. Because it is best approach is to make the last element, that is the most maximum value, as 1. Because it is better, like you have to just check whether it is greater than 1 or not. Okay, if you are taking any other value, so there are many possibilities. How many numbers are going to be lesser than equal to 1? It is either 0 or 1, right? So it is better to take greater than 1. Okay, so this is the reason, like in case you are having doubt, so this is the reason why we are going to do this. Okay, and this is a greedy approach thing. That's it from my side. Thank you.